Hello, ladies and gentlemen. Welcome to trigonometry. So we're going to start building the foundations of trigonometry today by talking about how we can measure angles a little differently than what you're familiar with. Now, I know you all remember angles from geometry and how to measure angles using degrees, and that's one way. Sometimes we need to talk about angles in more precise measurements, like in terms of decimal amounts of degrees, or other measurement systems with degrees, minutes, and seconds added to those degree measurements, okay? And as well, we're going to connect this also to angles measured in things called radians. So let's take a look. Let's just a little brief like geography overview. Here you go. If remember back when we learned about longitude and latitude, way back and whenever, I don't know, for me it was probably seventh grade geography or something. But we have this idea of built-in degrees on our globe, right? And a globe is a sphere. Our Earth is generally a sphere shape. And you might remember that each place on the globe is measured in degrees latitude and degrees longitude. So each location will have a latitude measurement, that is how far it is north or south of the equator, and a longitude measurement of how far it is degrees wise, east or west, from the prime meridian. Okay, so that's this line that goes down like this. So when we talk about those measurements, a lot of times to be more precise, we would have to go a little bit farther than 51 degrees. Sometimes we break those measurements apart into 0.4s, or we get even more precise in a certain GPS location using degrees, minutes, and seconds, that whole system, okay? So you'll notice I'm just trying to make the point that the whole idea of location measured by degrees is something that we're going to be dabbling with when we talk about trigonometry, okay? So we're going to be thinking about other ways that we can measure angles besides the traditional protractor number of degrees from geometry in more precise measurements, okay? So things like this are being used all the time in terms of navigation, in terms of GPS understanding, computer programming, things like that where they have to be more precise than just 52 degrees. We have to have other ways to subdivide those little extra bits of degrees that we go past to be more precise on our location. So here, this brings us to our notes. One way to do that is to talk about decimal amounts of degrees and how we deal with them. So if we have 52 and a little bit more, how can we talk about that? So here's one navigation system that's been set up. It's called degrees, minutes, and seconds. Okay, so DMS for short. DMS stands for degrees, minutes, and seconds. So we know from geometry that you could measure any angle using degrees. But sometimes you got an angle that was like, oh, in between a couple, right? And we didn't know exactly what it was. Well, the more precise we get, we realize we have to have a system for subdividing even a 1 degree difference. So each degree is divided or subdivided into 60 minutes. And the abbreviation for minute is one little apostrophe like that. And each minute is subdivided into 60 seconds, denoted by double apostrophe, like so. So you might see these in physics classes especially. And we should note that yes, this is called minutes and this is called seconds. And yes, they are using units of 60 here to divide those, but that is where the similarities end, okay? We're not talking about time. We're talking about a subdivision of a degree that we would talk about for an angle, okay? So note that 1 degree equals 60 minutes, and 1 minute is 60 seconds. Therefore, 1 degree would be the same thing as, let's see, 60 times 60, 3,600 seconds. So it's basically like understanding a centimeters, meter, millimeter sort of system, right? But those are base 10. We're talking about base 60 here. So that brings us to the examples that you see in your foldable. Degrees, minutes, and seconds. When we look at a decimal amount like this, 32.428 degrees, that's a decimal amount of degrees. You can see the actual decimal point in there, and it's just 1 unit, a degree. But we recognize that this is 32 and some other pieces of a degree. So when we want to convert this decimal amount into minutes and seconds, those are the other units that we can add on to the degrees here. Here's the steps that we go through to do that. We separate the whole number part from the decimal. So notice we have 32 here. So I know my answer is going to be 32 degrees. And then this is the decimal part that I want to convert into minutes and seconds. So we're going to convert that into the decimal part using the idea that that represents 1 degree is 60 minutes. So this represents a portion of a degree. So if I take that whole understanding, how do I then convert this into minutes and seconds? Well, I take that 0.428, that decimal part, and I multiply it by 60 to convert that into the minutes. Okay, so you're going to need a calculator for this because that's a portion of a degree, and that's what the minutes are, right? So 0.428 times 60 is 25.68 minutes. But wait, there's still a decimal part here, right? Well, I take that amount, if I have 0.68 of a minute, and I take that times 60 for seconds, then I can go, well, how many seconds would that be? Well, 0.68 times 60 is 40.8 seconds. So putting those ideas together, I have 32 whole minutes, or 32 whole degrees, 25 whole minutes, and this decimal amount of seconds left over. So 40.8 seconds. That is the decimal change to degrees, minutes, seconds equivalent describing that same angle measurement. So we can talk about it in degrees, we can talk about it in terms of minutes and seconds. Navigation systems tend to use a little bit of both depending on the type of system you have. So being able to understand both is kind of important. Let's take a look at another one where we convert the other way. So the degrees portion, when we have it in degrees, minutes, seconds, how do we convert it back to decimals? Same idea. You know this is 32 whole degrees, so 32 degrees. I have 25 minutes. I have 25 out of how many minutes needed to make a full degree? 60. So I have 25 out of 60 minutes needed to make a full degree. And then I have 40.8 out of how many minutes or how many seconds are needed to make a full degree? 3,600. So if I want to convert it all to degrees, I need to be thinking about how each little component makes up 1 degree. That's where the 60 and the 3,600 are coming from. So now if I go to my calculator and I type in what's 25 divided by 60, well, it's going to be some decimal, right? Well, that's 0.416666 repeating. But if I type this all in at one time, 32 plus that fraction, and you should be able to type that in your calculator with parentheses around it if you have a graphing one, okay? 25 divided by 60 plus 40.8 divided by, use your parentheses buttons, 3,600, you end up getting 32.428, which is what we started with the first time when we converted it back, okay? And that would be all in degrees. So 25 out of 60 needed for minutes, 40.8 out of 3,600 needed for degrees there, okay, for our seconds. So converting back and forth between decimal portions and degrees, minutes, seconds is one way we can talk about angles. So we have degrees, minutes, seconds, we have decimal degrees. Another way is to talk about angles in terms of no degrees at all. You know, forget about the degree system and just talk about them in terms of what's called a radian. Now remember, a radian is the angle formed, okay, so this is 1 radian, the angle that is formed when an arc is created that is equal to the radius. So it's a unit of angle equal to the angle at the center of the circle when the arc length is equal to the radius. So we found out that this little piece right here is 1 radian because my radius amount here equals my length of my arc here. This creates 1 radian. And every circle then has a fixed amount of radians, just like it has a fixed amount of degrees. We will always be able to subdivide every circle into 6 and a little bit more radians. And what was that again? That's right. Every circle can be divided into 2 pi radians. So while 360 represents a full circle in degrees, 2 pi represents a full circle in terms of radians. Equivalency, radian is about what, 36-ish degrees, so to speak. But a central angle of a circle having 1 radian if it intersects an arc with the same length as the radius. So then that brings us to the part where we might have to convert degrees to radians because that's a totally different system used to measure angles. And to do that, the best way to do that is just using proportions, ratios. So knowing that our part to whole will always equal part to whole when we have a proportion. So if I have 23 degrees and I want to convert it to radians, I'm going to use this sort of proportion setup every time. So angle in degrees is 23. Out of the whole circle in degrees is 360. The angle in radians, which is what I'm trying to figure out, so these are my degree measurements, I'm going to call that x for radians. Out of the whole circle, 2 pi for radians. Now if I cross multiply here to solve for x, 23 times 2 pi, of course that's going to be a gross decimal. 360 times x over here, and 23 times 2 pi over here. And then to get the x alone, I would just divide by 360. Now, rather than go to my calculator right here, one thing to recognize is I can just leave that pi alone and just deal with the 23 times 2, which is 46 pi over 360. And now I can just leave that pi sitting there and just simplify the 46 out of 360 fraction, and you just leave it as a fraction, right? And make that become 23 out of 180 pi. That would be 23 180ths pi radians. Okay, typically when we have a radian measurement, we do not multiply that pi in there. Okay, leave the pi out, it's just going to be a part of your answer. Just like 2 pi r, you can leave it in terms of pi. Okay, so let's take a look at the reverse. What if I have a pi measurement in radians and I want to convert it to degrees? Well, I would just change where the x is in the proportion. So x over 360, those are my degrees, equals my radians, 2 pi over 5 out of 2 pi radians. Okay, 2/5, yeah, that's a fraction within a fraction. It's okay, we're just going to cross multiply. I'm going to cross multiply this way, I get 2 pi x. If I cross multiply the other way, I get 360 times 2 pi over 5, or you can just take 360 times 2/5 and let the pi sit there, which is, kind of a nicer thing to do. And then you don't have to deal with that. That's 144 pi. Okay, and then what are we going to do? Well, we're going to get the x alone, so we're going to divide by 2 pi. Divide by 2 pi. These cancel here, and then, of course, my pi's are going to cancel there, and I'm just going to take 144 divided by 2, which gives me 72. So 2 pi over 5, or 2/5 pi radians, is equivalent to 72 degrees. Okay, so we want to become familiar with different ways to measure angles as we go into this trig unit. Okay, so here's 3 different ways we can measure and how to convert in between. I want to thank you for taking good notes. Kincaid out.